This video is an introduction to random variables in 6.1, where we will mostly focus on discrete and continuous probability distributions. So first of all, we need to realize what a random variable is. So a random variable is any way that you define a numerical value to a chance process. So for example, if the chance process was flipping a coin, if I did it 3 times, the random variable would be the number of heads that you could get. So flipping a coin 3 times, that right there is your chance process. And your variable is going to be the number of times it lands on heads. So that x is your random variable. When you list all of the possible values of a random variable, that's called a probability distribution. So this video is going to focus on probability distributions of discrete variables. So a discrete variable is something that you can list every possible outcome. So it's a fixed number of outcomes. There's no gaps in between. So something like shoe size or grade in school, those are discrete because it's not like you're in ninth and a half grade, you're in 9th grade, you're in 10th grade. Those are discrete variables. So let's take a look at an example of a discrete probability distribution. You're selecting high school students at random. You're going to define the random variable x to be the number of languages spoken by that randomly selected student. The table below gives the probability distribution of x based on the sample of students from the U.S. Census at the school database. So the first thing we're going to do is show that the probability distribution is legitimate. So we talked about this in Chapter 5 and in class. There are 2 things that need to be true in order for it to be a probability distribution. The first thing is all the probabilities need to be between 0 and 1. So all the probabilities are between 0 and 1. And we can check, okay, 0.63 is 0.295, 0.065, 0.008, and 0.002. Those are all between 0 and 1. And the sum of all the probabilities need to equal 1. So 0.63 plus 0.295 plus 0.065 plus 0.008 plus 0.002, that needs to equal 1. The sum of all possible probabilities needs to equal 1. Next, we're going to make a histogram that describes this probability. So on the x-axis, I'm going to put x, my number of languages spoken. So they could speak 1 language, 2 languages, 3 languages, 4 languages, or 5 languages. And normally on a histogram, you would have a range of values. But since this is discrete, there's no in-between values, so you don't really have a range. So your tick marks are going to go in the middle of the bin or the box of your distribution. So we've got to go at least up to 64. So let's see. I'm going to count by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 7, 8, 9, and 1. So the probability that a randomly selected person speaks 1 language is 0.63. So there's the first bin. The next one is 0.295. So there's that bin. The next one is 0.065. Right there. 0.008, which is even smaller, and 0.002, which is almost 0. So there's the distribution shown in a histogram, and I'm going to label my axes. X equals the number of languages spoken, and then my y-axis is P of x, the probability that X happens. So we can describe the shape of this distribution. The shape is skewed right. So usually you'll have to describe the shape of a probability distribution. And now we're going to calculate some probabilities. So part C, what is the probability that a randomly selected student speaks at least 3? So at least 3 includes 3. So it'll be probability that X is greater than or equal to 3. And the way you do that is you just add up each of the different probabilities, 3, 4, and 5. So 0.065 plus 0.008 plus 0.002, that equals 0.075. And if we want to interpret this probability, that means that there is a 0.075 chance that a person speaks at least 3 languages. Now part D looks like you're doing the same calculation, but it says what's the probability that a randomly selected student speaks more than 3 languages? So more than 3 languages does not include 3. So probability that X is greater than 3, you don't include 3, so it's just 0.008 plus 0.002, which is 0.01. It does not include 3. Now, question E is a throwback to chapter 5, so hopefully you remember something from chapter 5 so that we can calculate this probability. So question E is asking, given that the student speaks more than 1 language, what's the probability they speak 3 languages? So it's saying, what is the probability they speak 3 languages given that the student speaks more than 1 language? And this formula is on your formula sheet if you forget it, but this is the conditional probability formula. So it'll be the probability that X equals 3 and X is greater than 1 over the probability that X is greater than 1. So now we can look at the table to plug in our values. So the probability that X equals 3 and is bigger than 1 is all the time that X equals 3. So that's just going to be 0.065. The probability that X is greater than 1 is everything but X equals 1. So you just add up the probabilities for 2, 3, 4, and 5, and you get 0.37. So this probability, if I divide that, is 0.176. Let's take a look at another example. Now we're talking about a roulette wheel. So one wager players can make in roulette is called a corner bet. To make this bet, a player places his chips on the intersection of 4 numbered squares. If one of these numbers comes up on the wheel and the player bet $1, then he gets his $1 back plus $8 more. Otherwise, the casino keeps the original $1 bet. If X is the net gain from a single $1 corner bet, then the possible outcomes are -1 or 8, because they're not talking about the total gain, right? Because technically they're getting $9 back, but they put $1 in. So the net gain is only $8, or they lose their dollar. So their net gain is either -$1 or $8. Now, we could look at a roulette board, but here are the probabilities already, just so you have it right there. If the player were to make this $1 bet over and over and over again, what would be the player's average gain? So let's say they played this game 38 times, because that'll be an easy fraction, right? If they played 38 times, they would expect to win 4 times. So you could make $8 times 4 times, or you will lose $1 the other 34 times. And divide that by 38, that's the total amount of times you played, that's negative 0.05. Now when you've got a probability distribution like this, notice how your fraction is kind of built in to this mean. So we have 8 times 4 over 38 and 34 over 38. So the other way you could write this is you could have also written this as 8 times 4 over 38 plus negative 1 times 34 over 38. So on average, if I played this 38 times, I would expect to lose 5 cents. Your net loss would be negative 5 cents. Like your average gain would be negative 5 cents. So on average, and this means something different in probability than how you expect it. On average, you would lose 5 cents over time. So it's not like the average is negative 5 cents, but in the long run, you would lose 5 cents over time. And you can't always get the exact value that is the mean, but that's what you would expect to happen. So another word for mean then is the expected value. It's what do you expect to happen? Now this formula for calculating the mean is on the formula sheet, but it looks a little confusing when you see it. On the formula sheet, it looks like this: expected value of x equals the sum of all xi probability of I. So notice how in the above example, this was the x value you could get, and this was the probability that you could get it. This was the x value, this was the probability you could get it. So if you multiply all those x's and p of x's together and then add them up, that gives you the expected value. So that formula is on the formula sheet in case you forget it, and they use the word e of x. Now when you have a long table or a large probability distribution, you can calculate this in your calculator. So in your calculator, you're going to put all the x's in list 1 and all the probabilities in list 2. Then you're going to go to one variable stats, and you're going to put the list is going to be L1 and the frequency is going to be L2. And you can find the mean and the standard deviation from that list. So we'll practice doing this in the calculator in class. Now once you get a mean, you have to know how to interpret it in context. So the wording for that is the expected and then x in context is e of x, and then use the correct units. Or another way you can say it is we would expect and then x in context to be about, and then use e of x with the right unit. So pause right here and try this next example on your own using the languages example from the previous page. You can try using the calculator to get this value, or you can do it by hand. And then when you're done, you can press play and see if you got it right. So hopefully you got this answer right, and notice how your expected value comes out to a decimal. even though it's not one of the possible values that you can get, 1, 2, 3, 4, so on, it's still the expected value, and you do not round. Keep it a decimal. Keep this a decimal. Now, I'm sure many of you were thinking while we were calculating this mean, but wait, where's the standard deviation? Every mean has to have a standard deviation. Well, I'm glad that you were thinking that, because we're about to calculate the standard deviation on the next page. So one thing we haven't talked about a whole lot, probably since chapter 1, is variance. Variance is the standard deviation squared. And usually you have to convert to standard deviation, or from standard deviation to variance when you're adding or multiplying different standard deviations together. That's the main use of them. So if you ever want to get to the standard deviation from the variance, you can just take the square root, or vice versa. So before we actually calculate these, let's remember what the definition of standard deviation is. So recall, standard deviation is the average distance from the mean. So if we put it in the context of this type of problem that we're doing, so the standard deviation of a probability distribution is going to be the typical deviation from the expected value. Now, the formula for variance is on the formula sheet, but it's very complicated and rarely will you calculate this by hand. You will mostly rely on the calculator to do this. So the way that it looks on your formula sheet is it'll say variance of x equals the sum of the distance from the middle you are squared times its probability. So it's your x value minus the mean squared times the probability of that happening. So if you want to get the standard deviation from that, then you would take the square root of the variance. And that is why the standard deviation is always positive, not to mention that it is a distance, which you won't have a negative distance. So in the calculator, you would type list 1 is your x variable, all the possible x's. List 2 is the probability of x, all your probabilities. You're going to do one variable stats with your x list as list 1, and your frequency list is L2, and you're going to look for the x bar and sigma. Those are going to be your two standard deviations and mean numbers that you look for. And that's how you get the mean and standard deviation in the calculator, which we'll practice that a little bit in class, but you can practice that now with plenty of examples. And you have to be able to interpret a standard deviation as well. So the general way that you interpret standard deviation is a randomly selected and then x variable in context will typically vary or will vary on average from expected, so don't say from the mean anymore, from the expected by, and then standard deviation. So let's go back to the languages example. We're going to calculate and interpret the standard deviation of the languages. So from the previous page, we got that the expected value was 1.457. And sometimes they'll use the notation mu of x. So just be aware of that, especially inside formula sheets. We're going to do it by hand once, and then you can pause and try it in your calculator to see if you get the same answer. So the formula for the variance, we don't have a formula for standard deviation, is the sum of all of your x minus mu squared times probability. So we've got one language minus 1.457 squared times the probability they speak one language plus two languages minus 1.457 squared times the probability they speak two languages plus 3 minus the mean 1.457 squared times the probability they speak three languages plus 4 minus 1.457 squared times the probability they speak four languages, and then plus 5 minus 1.457 squared times the probability they speak five languages. And when you type all of that into your calculator, you get 0.4501. Don't stop there, that's only your variance. So your variance is 0.4501, which means your standard deviation is going to be the square root of that, 0.4501, which is, when you type it into your calculator, 0.6709. So you should pause here and try to do it in your calculator too, so you can become comfortable with using the calculator. And when you're done with that, we're going to interpret the standard deviation as well. So a randomly selected person will speak, or I'm going to say a randomly selected person's number of languages spoken typically varies from expected by about 0.6709 languages. Now I did this by hand in the example where we calculated the standard deviation and when we calculated the mean. Both of those can be done in the calculator, and it can be a time saver if you're good at using the calculator. But be careful of that. You want to make sure that you show enough work. So show what you're typing into the calculator. These are things you would want to show if you're using the calculator. L1, and then label the variable, like write out what variable you put into L1. L2, write that you put probability of X into L2. Write that you used one variable stats. List what X bar equals. List what standard deviation equals. Show all your work and you won't lose a lot of points. Now this was the longest video you'll have of this chapter. It just had a pretty big introduction. So if you got through this one, the other ones are much shorter, don't worry. And please watch this and pause it, and don't just not even pay attention just so you can copy down the notes. Rewind, pause, do whatever you need to do so that you can fully understand it. We're not going to go through these notes in class. We're going to focus on doing examples in class. So get the definitions down and start understanding what's going on so that you can fully grasp this chapter. See you next video.